Okay, this is Dr. Benjamin again. This time we're going to try another uh, single sample t-test. This one, the scenario is meant to be fairly straightforward. What you're going to be, imagine you have a new sheriff who ran on a platform of reducing emergency response times in a community, maybe a very rural community. We're talking a whole county, maybe full of very small communities. Okay, and it's believed that on average it takes 30 minutes for the first responders to arrive to their locations, which seems excessive to the sheriff candidate and eventually sheriff once the individual gets elected. Well, they promised to make some changes to some procedures so that they can make things better and get response times faster. You see that for the first month, there are 10 um, actual uh, 10 actual initial calls, and you can see the response times for those. Okay, and you can see some of them really are under 30 minutes, some of them aren't. We'll see what happens. Maybe it really did get better. But again, a month is not a lot of time. Sometimes you just don't know. But we're going to do the same process again. We're going to do a one sample t-test. Okay. And then we're going to do the same things we did before. We're going to go ahead. We're going to click effect size because we're going to want that. We're going to want descriptives when we're ready to populate. Since 30 minutes is believed to be the average response time before the new sheriff takes over, we're going to make that our test value, 30. Okay. And just like with the previous example, we're going to go ahead and check to make sure the normality assumption was not violated. Okay. Once we've done that, we are ready to go in terms of populating this next panel to the right. And so I'm going to get my variable moved over and watch it compute. And it may take a little time, but here it is. And you can see again descriptives. Sample is 10, mean 28, so 28 minutes now. That's actually a bit of an improvement, at least on the surface. Standard deviation 3.71, standard error 1.17. This tells me that there is a good deal of variability here, which could pose some problems. You might have noticed a lot of variability in the response time. So when you were looking at the data a moment ago. And again, you can see that the assumption of normality was not violated. We have literally nothing to worry about there. We're in great shape. T statistic, T is minus 1.70. Okay, and so definitely response times are on the lower side than they were previously. Degrees of freedom, 9, makes sense. Again, you've got one of your scores set constant, the other 9 free to vary. P-value, this is kind of where things get to be a bit of a bummer. You end up with a P of 0.123. That's not going to get anywhere near the P is less than 0.05 that we really look for. So this one doesn't even squeak through. Remember, we did a two-tailed test, which is the default. Even if you wanted to p-hack a little bit and say, well, look, if I run a one-tailed test, I'll get significance, everything will be hunky-dory. Sorry, Charlie, that's not going to work. And then you've got a Cohen's d that looks like it could be potentially moderate. So this is one of those cases where you'd probably, if you were the one of the sheriff's consultants working on this particular project, you probably say, hey, let's run another sample, let's make it larger, let's wait several months and get more data then we'll really know whether your procedures are working. Um, but right now, at best, everything is really inconclusive. We certainly can't reject the null in this case. We have to accept the null. So that's essentially it. And again, if we were to go ahead and do some R code, if we put it in syntax mode briefly, you can see what the code would be in order to get the t-test to run, and go ahead and get rid of that. But it's useful to see what our code looks like and what the outcomes would look like. This looks a little cleaner, but that's why we have word processors and all that. We can clean up things later. One thing I do like about Jamovi is that you have everything in one location. You've got your data, and you've got your analyses all together if you want them. You want to look at them together. Jamovi also gives you references, so you know where their statistical routines came from. And so that's always helpful to have too. I mean, they try to be as transparent as possible, which I think is a wonderful thing. Okay, so anyway, that's the other one sample t-test that we did in class for those of you who were not able to make it today. And get this, run through what I did. Watch this video again as much as you need, and let's see what happens. Okay? Alrighty. On that note, take care.